Hi, everybody. It's good to be again in Data Science Alone. This time we have a guest, Nick Brown from IHS Markit is joining me. I'm Asaf, co-founder and CEO of Iguazio. And today we'll be talking about lesson learned in operationalizing machine learning at scale. At Iguazio, as some of you may remember from our previous session in the previous DSS event, Iguazio have been focusing on the problem of operationalizing machine learning. It's not enough just to build models. Models need to be deployed in production. Models, as our slogan says, we are bringing data science to life. How do you do that? How do you take those artifacts of the model that you build in your development environment and take it all the way to production at scale? For that, we've built our data science platform, and today will be the topic of our session. And we've been working with Nick from IHS Markit for a while now, and I'll hand it over to him to talk about the whole journey IHS Markit had when it comes to the space of data science. Nick.
Thanks, Asaf. For co-presenting with me, I want to thank the Data Science Salon for having me and for creating this community. And I want to thank the audience for being here today, because I think what we're talking about is really critical, and we're at a time where we can't ignore it anymore. So, as Asaf said, my name is Nick Brown. I'm a senior data scientist with IHS Markit. Worked in a number of different areas, but for the last year or so, I've been focused on machine learning operations. Before we get into the talk, I think it's important to understand exactly what IHS Markit does. And really, the most important part to understand is that we help our customers make informed decisions. And how we do that is we combine, importantly, industry expertise, technology, and data science to create value through information. So it's not just data, it's information. We operate in three primary verticals, so transportation, energy, and financial services. We enable growth and performance and efficiency through the data and software that we have, and especially insights that are derived from that. And overall, we're an information company, truly. And so before we get started, I think it's important to understand that the three verticals that we chose, it's important that they add value on their own. So if we're talking about energy, it's valuable for people to know how much oil is forecasted to come out of any well in the world at any price, for regulation agencies, oil and gas companies, but also we can use that in combination with our traditional financial services data for commodity models to improve all of our financial models that we're using. In transportation, it's valuable for companies like Boeing to be able to assemble aircraft safely using the regulations and the standards that are out there. But it's also useful in text mining to understand if regulations are tightening or loosening in certain industries and engineering. And finally, in finance, it's important that we are able to predict dividends, generally speaking, just for that goal. But that's useful in a variety of different financial and quant models. And so as a company, we're truly focused in not just providing value in each individual vertical that we have, each individual business line that represents, but in the synergistic whole of all of those things together, especially supporting our financial services with alternative information. And so from Boeing to the Bank of England, we're critically relied upon for the information that we provide to make the best decisions, with what we have. And so the scope of what we do is incredibly large, and I could spend a lot of time on that. But, really what we need to start talking about are enterprise data solutions. It's something that, this diagram here is actually borrowed from a paper that came out in 2015. And it's this mindset, ML ops. The data science isn't over when the model is finished. We have to be able to go all the way from idea to production. That's what it means for a data scientist's job to be done. And so what we're traditionally as data scientists taught to think about is that small box in the middle there, that ML code. And so that's your TensorFlow, XGBoost, Dask, all that pre-preparation work. But once the models get business and engineering approval, there are so many more concerns than just that small box. And you see them listed here. And this has, again, been known for a while now. And so when you productionize models, that requires things like answering, how do we use the features from our training in a real-time framework when we're serving these models? How do we make sure that there's not a skew between those two things? How do we scale models or our pre-processing to respond to spiking load? And how do we make those things independent from each other? Should a model be retrained due to concept drift? Right? That's a legitimate question in the monitoring side of things, but how will we know? So those sorts of hooks have to be there in the serving infrastructure and even in feature extraction infrastructure to know when we need to start thinking about updating models in production. Stop, next slide for me, please. And so the answer here is a data science platform. And this has been recognized for a while by some of the giants in the field. But what are the benefits, right? What are the benefits of a data science platform? Because it can feel like an investment, and it is. But the biggest one, number one for me, is that research and production are not separate. They become one. And so that means that we can iteratively develop models and deploy in days and weeks and understand what the weaknesses and strengths are in research and production. And there's no rewriting, there's no handoff. It's not this awkward process of trying to get models into production. The next one is that it really enables specialization of each of the members of a data science product team. And that means that, whereas before 80% of a data scientist's time was being taken up by all this admin and plumbing work, now they're able to specialize, meaning greater output, more experiments. And it really does encourage teams to work cross-functionally instead of in silos. And then finally, in the age of Docker and containerization, best practice is to build reusable pipelines and components so that our workflows can be automated. And whenever we need to customize something, we can. But if we have internally pre-trained models, internal pre-processing steps, those can be set aside that a data scientist can just pick that up off the shelf. And so that means more time for experimenting. And then, so what happened? Well, I came from a background where it was important that we were able to do real-time pricing optimization. There were lots of manual efforts that we tried for productionizing machine learning. It just wasn't working. And so I saw firsthand the difficulty and expense of designing a production machine learning system. When I left my last position where I learned a lot of this stuff, I had moved to my IHS Markit, I saw that we didn't have this in our own infrastructure. And so I decided to document my experience. And so what came out of this was a set of functional requirements that I've seen as necessary for a data science platform. And it's not just focused on data scientists, which I think is critical because we need to start thinking about the data science product team, just far more individuals. It's focused on creating that cross-functional collaboration with our data engineers, DevOps engineers, software engineers, the product owner, everybody, and why these requirements will enable growth and really provide, as I say here, a rapid path to production, and not just rapid, but a reliable path to production. Beyond that, the secondary goals are pretty much just good science. We want to focus on being collaborative. We want to focus on confidence in our models in production. And we want to focus on being able to reproduce anything from an experiment to a model in production, because when things disappear, get deleted, there's corruption, you need to be able to do that again. And I don't want to pretend like this is just out of my own experience. I had amazing mentors at my previous position, but also the big tech giants, we're standing on their shoulders. They've been releasing papers on this for the last 12 years, really. And I list those at the end of the functional requirements, and we encourage everybody that we become collaborative. This is going to be open source. Anybody can contribute to it. And I really want to see us as a community grow and understand that we've got some great examples. Let's make this available to as many people as possible. And so, funny enough, like I said, I noticed we didn't have this solved at IHS Markit, so I started looking in the open source community. Asaf. And what I found was Iguazio. And it was an interesting way that I got there. I actually came through the Kubeflow open source ML orchestration project and saw their work with Nucleo and got really, really excited because it was an open source serverless framework that was stateful, lots of interesting stuff. I could go on and on about it, but we are on a time frame here. But really amazing. And then I noticed that they were also doing other open source contributions. And so, for me, a data science platform, it's important that it's not closed off. It's open. It's about combining many machine learning libraries and products into a cohesive set of workflows and a mesh that's extendable too. Any of us can contribute to these projects, and they are truly able to be used in an open source fashion. The next thing that I think is really important about Iguazio is that they are so focused on the right problem. Too many data science platforms out there right now are focused on getting more models out there. And I've talked to many of my colleagues, and I think we can all agree that the problem is not that we're producing too many models, it's that they're never actually making it out there. It's a famous statistic that anywhere between 75 to 90% of models are never making it to production. That's the part that Iguazio is focused on. And so that means creating value for the data scientists because we're able to deliver value to our business partners. And then finally, not only were they first movers in this space, but they have been totally transparent and really see the full picture of machine learning and data science and fit a lot of the functional requirements. And we're very excited to hear about them and to incorporate them into the open source that they are developing. So without further ado, I'm going to turn it back over to Asaf to talk more about Iguazio.
Thank you, Nick. So let's just dive a bit under the hood of what is it inside our platform. And if we look at it, let's cut it into three layers. Starting from the ground up, where we talk about data. And as Nick said before, when you talk about the problem space in machine learning, it goes beyond the actual part of machine learning. It actually starts with the data. There's so much data problems that need to be solved in the building those application pipelines that in the heart of them are using machine learning. But how do you get the necessary data at the right time to the right models at the right scale? And for that, we developed a unique a set of data capabilities, starting with our real-time multimodal data layer that is in the heart of empowering our feature store that we'll talk about later on. And all of that is always combined with the ability to ingest data from existing databases that you have in your organization and other data sources like your operational systems, your streaming data that is coming from multiple sources, external, internal. All of that has been a huge focus of Iguazio since we founded the company 6 years ago, about the ability to place a strong data engine in the heart of this application that will allow you to actually do all of those data ingestion things related or the serving of the models, and also at the end of the day, getting the actions done. And all of them eventually need to rely on a strong data repository that powers our feature store. The next layer is a set, and that goes to what Nick alluded around open source. In the heart of our solution, we have two major open source initiatives that we're driving. One of them is called ML Run, and the other one is called Nucleo. Basically, with ML Run and Nucleo, it's a combination of the ability to run an entire life cycle of a machine learning application from the early stages of the model creation all the way to running it in production, orchestrating the whole process, making it repeatable, making it explainable, and in the heart of it, being able to run it in an open system where you can integrate. I mean, there is so much innovation happening on a weekly basis when it comes to different pieces of open source projects that focus on a specific part of the pipeline. We have built a platform that allows you to operationalize all of that and integrate in a dynamic way these projects that are run and as a service within this platform, as a managed service, where you can actually, as the developer, whether you are the data scientist, the data engineer, you turn on these services in a self-service way without the need to actually call the DevOps folks to build something, to wait for them for a few weeks. All of that is actually automatically turned on when you see there's only snapshots of the different technologies that are integrated as part of our platform. And at the upper layer, this is where we have kind of all wrapping it together, the combination of an online and offline feature store that is serving the entire life cycle of the machine learning application. There is the orchestration of it, and then another very important aspect is the ability to run these applications in real time. We see a huge trend in the market for many companies, whether it's in fraud, that they were doing detection before, and now they're moving to prevention. You have to do it in real time. So many applications in the space of retail, in the space of predictive maintenance, that require real-time capabilities. And obviously, in financial services, this has been the vertical that was using real-time data by far first compared to other verticals in the market. And that leads me to the type of use cases and customers that we've been serving with our platform over the last few years, from fraud prediction, again, allowing financial services, whether it's payment companies or credit card companies, to detect fraud, actually predict the fraud, and prevent it altogether rather than detect it and deal with it after the fact. The next one is risk modeling. This is where we see more and more application of AI. If it was more of a kind of HPC application in the past, now we see more and more predictions being used in this risk modeling. When it comes to real-time recommendations, we see credit card companies now integrating such services within their overall service, and they have a unique position where they actually get data from multiple merchants, combining it with their own data, and applying all of these recommendations in real time. Great application on top of our platform. There are many more. We've also been operating in the insurance space, but I'll leave it for another session. A few words about the company just before we go away and answer questions. So we've been around, as I said, for 6 years. We've seen great growth over the last few years. Been working with large partners such as the cloud vendors and NetApp, NVIDIA when it comes to GPUs, that we see more and more GPUs deployed in AI applications. Also always nice to brag about all our mentions in the industry analysts. But it's all about community. And this is where we encourage you to join our MLOps Live community, where we have dynamic and lively discussions about problems and solutions within the MLOps space. We'll be happy to address those questions, and always great to be inspired and inspire, and we'll be happy to answer questions now. Thank you, and thank you, Nick.